Hi, good day. My name is Jit Sheng, and my supervisor is Dr. Anwar bin Jafar. And my PSM2 title is Real-Time Monitoring and Fault Detection in Solar PV System using IoT and Machine Learning. Here are the research gap between my current proposed project with the recent 5-year previous study. And here is the problem statement. The first problem statement is a manual inspection is time-consuming and labor-intensive. And the second problem statement is this lack of the fault detection system that will cause late fault night diagnosis. And I'm going to align my objective with the previous problem statement. And my first objective will be to develop an IoT-based monitoring system for real-time measurement of solar panel parameters. And my second objective is to design a low-cost, user-friendly, and scalable IoT solar PV monitoring and fault detection system that replaces manual inspection through continuous monitoring. And this is my scope of work, which is my coverage of my project. This is the placement of my whole prototype. And here's the methodology flowchart. It is divided into two major sections, which is first objective and second objective that I mentioned just now. And to conclude it, it is starting from sense and followed by process, classify, log, visualize, and alert. And here is my system architecture flow diagram. I will talk about the high-level block diagram. And it is divided into 3 layers, which is input layer, processing layer, and output layer. As what you can see, I am collecting light intensity, temperature, current, and voltage at the input layer. And in the processing layer, I'm using the ESP32 to read the sensor data, run the TinyML inference, and also control the relay and the output. So the output layer is the Firebase. This is the database that I use to collect the data, and it is split into 2 branches. The first branch is logs, and the second data from the AI result. Now I'm going to talk about the local web dashboard. And this is the locally hosted web dashboard, and it is showing the collected data and the power. The power is calculated using the P equals to IV formula. And you can see the voltage, current, and power live graph, which is updated every 2 seconds, and followed by the temperature and lux live graph. And this is my local web dashboard. It has a Firebase history section that allow you to fetch all the data from the logs under the database, and you can export it into CSV file. So I also implement a robot feed that will present all the data that has been provided from the AI result, and it will show normal case when the normal class is classified. And during short circuit is detected, the AI diagnostic robot feed, it will show these notifications and followed by the disconnected wire. And for the Telegram alert, it will trigger every 10 minutes per alert. And this is the message when disconnected wire is detected. And also this one is short circuit is detected. And after you fix it, you can see it will change into recovered short circuit clear and followed by the disconnected wire. And this is a cooling fan relay, and you can control the fan manually on and off. And you want to set it to auto mode. Auto mode when the temperature is higher than 45 degrees Celsius, it will turn the fan on, and it will automatically shut down the fan when the temperature is go below 40 degrees Celsius. And this is my dataset representation. This is the average of my collected data that used for training of my fault classes. TinyML model. Here is the weather dataset class distribution. And this is a plot of the average of the collected data that will be used for the weather classification TinyML model training. And here's my TinyML workflow. I joined 2 TinyML model into only 1 library. Here's the result. I am tuning the hyperparameters such as learning rate, the epoch, also the batch size. And the final tune optimization attempt is achieve the highest accuracy and the lowest loss, and it is selected. Also same for the weather classification training result. As what you can see, we are achieved 92.3% accuracy and 0.27 loss. Now I will talk about the future work and conclusion. For the future work, the first is outdoor long-term dataset, which means we will try to implement this prototype outside for around 6 months or go beyond higher. Because currently the dataset is more as it only deploy for 1 month only. And the second one is more fault classes, and currently it is supported with the short circuit and disconnected wire only. And for the future work, we might increase the more fault classes such as shader or other case or the degradation. And the last is a multi-panel deployment. This is suitable for the large-scale solar farm, which implement this prototype onto their edge solar panel. And here are my SDG. First one is the SDG 7, affordable and clean energy, and the second one is SDG 9, industry, innovation and infrastructure, and the third one is SDG, responsible consumption and production. This is the 3 SDG that related to my project. I will show about my demo of my prototype later on.
Hai đứa giờ nó nhìn nào sang chỉ cầu cầu hay cái bọn mình. Ok, cảm ơn. Rồi đó. Này nghĩ vào đó nè, cái biết